Okay, so in this lecture I'd like to go to the model folder. Okay, so I'd like to develop the model of a problem and also of a game, right? So let's start with the problem model, right? An exercise, a problem. So I'm going to call this problem model, right? A math problem. So problem model. So we should think, what do we have in a math problem? Maybe we have a couple of numbers, for example. Now I'm going to restrict to addition. But you might decide that you want some arithmetic model, right? So you might have a binary operation as part of your problem model, right? So I'm going to let the problem model conform to identifiable. This is really standard. Now I'm going to have two numbers. I'm going to call this number 1 and number 2. That makes sense. And we're also going to add in the level of the game into this model. We might reconsider this later, but I decided to leave the level in there, and you'll see why in a moment, because it will help us create the problems. We want to create a random problem. Now, in addition, we'll have solutions, which will be an array of ints. Now, I chose to call it solutions. It's actually not precise. What I mean is solutions 0, the first element, right? The 0th element is the answer. It's the true answer. And the other elements of this array are distractions. In other words, they're false. They're not correct. So maybe instead of solutions, we should call it options. I'm just going to keep it solutions, even though it's not exactly precise. And let's actually add a computed property called answer. So the true answer, well, by design, it'll be solution 0. And I also would like the ability to check if a solution is correct. So check solution. So the user might enter a value, right? Select a value, and I want to return true or false. So first of all, solutions should never be empty, but just to be on the safe side, I'm going to first test that the solutions is non-empty, right? Solutions.empty means it's empty, so I want it to be non-empty, just to be on the safe side. So if the solutions is non-empty, which it should be, and the value is actually, the value the user chose is actually equal to the answer, then return this, okay? But you see, this is a function with only one line, so we don't need the return. I can just drop that. Okay, so we're good there. We have the general structure. Now I'd like to create an initializer for this structure, because I'd like to initialize solutions. And I want our initializer to depend on the level that we're on. Like if we're on a lower level, maybe we'll want a 1-digit problem. If we're at a higher level, maybe we'll want a 3-digit problem, for example. Okay? So first of all, self.level will be equal to level. So self.level is just the actual level in our structure. And this level is the input. Now we need to initialize all of our variables. So ID is already initialized to unique user ID. We need to initialize the numbers. We're going to randomly define them. The level is given, and we need to initialize the solutions. Okay? And actually, I'd like to move the init. No, we can leave it down here, actually. But I do want to fold the code. It's annoying to see. Okay, great. Now, I want the lower value, the lower possible value, to be level -1, or actually to level. It'll be equal to level, and let the upper value, So what do we mean by upper and lower? Will be 5 times the level. So if we're at level 1, the lower value is level minus 1. The lower value is level. Okay, I don't like that. So let's rethink this. I think what I prefer is the following. So let's think, if we're on level 1, 1 minus 1 is 0, and 0 times 5 is 0. So the lower bound for our digit that we're going to randomly select will be 0. And if level is equal to 1, 5 times 1 is 5. Now if we were to go up to level 2, 2 minus 1 is 1 times 5. So we'll be selecting a number from 5 to 10, from 10 to 15, from 15 to 20, from 25 to 30, depending on the level. So it takes him a little bit to grasp exactly what we're doing here. So int.random in lower all the way up to upper, and I'll include upper. So I did 3 dots to include upper. If I would do 2 dots and less than sign, it would not include upper. And the same thing for self.number 2. So I've selected random numbers from between lower and upper, okay? And notice as the level increases, lower and upper increase. So that increases the difficulty of the problem depending on the level. Great. And I want to construct a variable. So new solution. This will be an array of ints. Now, first of all, I'm going to append to the 0th position the answer, right? So what is the answer? Well, let's think. The answer is just number 1 plus number 2. That's the answer. It's not solution 0 yet because we haven't defined solution 0. If I would try to write that, it just wouldn't work, right? Solution 0 is undefined. I cannot use that. So over here, I'm going to put answer. And yeah, cannot use before all stored properties are initialized. So that would crash anyways, right? We don't want solution 0. So new solution.append, that means new solution 0 is number 1 plus number 2. Next, I want to start adding distractions. Now, we want to create answers, right? So I want to choose randomly select a value that's a little bit below the answer. So let's think. Let's think something a little bit below the answer. Say answer minus 5, right? But you see, if the answer is the number 2, then 2 minus 5 is negative 3, and that just doesn't make sense. So what I'm going to do is the following. I'm going to say, let's take the maximum value between, say, 1 and answer minus 5. So if we become negative, I'm just going to take answer minus 5. Okay, great. And actually, let's let this even be 0 down here. Now this will rarely ever occur, but still we want our random distractions to make sense. So above answer is just 5 points above the answer. So if our answer is 27, then below answer is 22, and above answer is 27 plus 5, that's 32. And now, 4. Okay, I can write I in 1 to 3. Oh, and I do want to add another thing, sorry. Let's do new solution.append answer plus 10. What does that mean? That means if our answer is 27, the first distraction, so this is the true solution at solution 0. And this will be a distraction. Now, that means it's an incorrect answer. So if the true solution is suppose 27, then the distraction is kind of nearby, 37. I added 10 so that the final digit will be the same. It just is supposed to confuse, whoever's playing the game and make the game a little bit more difficult. But you see, we can work quite a bit at creating some interesting logic. Okay, and it might have been wiser to just take all of this logic here and creating the answer to put it in just a separate function. But we'll do that here. So far, new solution has 2 values, and I want 2 more values, right? So I'm going to go from 1, or actually I can just do this. 0 to 1, or better yet, let's not even complicate things. Let's just do new solution dot append. I was going to use a loop, but I don't need to because I just want 4 elements and I already have 2. So we want 2 more elements, right? So just to be clear, this is solution 1, the first distraction. And then we're going to have solution 2 and solution 3, which again, the naming isn't the best, right? It's not really a solution. It's an option. It's a distraction. Only solution 0 is the correct answer. And now what I'd like to do is int dot random in below answer to above answer. Now, there's definitely a logical bug here. Oh, and before let's finally define solutions. So self.solutions will be just equal to new solution. Great. And now the initializer works, but there is a logical bug. The logical bug here is the following. First of all, I want all of our distractions to be different, okay? And I don't want them to coincide with the answer. So the first new solution, right? New solution 0, that is the correct answer, right? It's just number 1 plus number 2. That's correct. At solutions 1, we're just adding a 10, so we're definitely getting a new value. Now over here, new solutions append, it's kind of complicated. Because if our true answer is 27 and we randomly select a value between 22 and 32, then we might hit 27. And same goes over here. Now there's many ways to resolve this. One way to resolve this would just be to go from answer plus 1 to above answer. So answer plus 1, say if the answer is 27, then answer plus 1 is 28. And then we're okay, right? Then we don't have to worry. This is just going to be fine. Next, I can start from below answer up to the answer. And see, I might select answer by mistake, so let's do less than. And now I know that there's no way that any of these can coincide. There's no way possible that they can coincide. Everything is unique. So great. So you see that the logic can be quite complex, and we could think of other ways to distract the player of the game. But this is already a good start. Okay, great. So we're done with the problem model. In the next lecture, we'll move on to the game model. Okay, so we're going to have a game model, and we'll also have a corresponding view model. So we still have quite a lot of work. Right now we're working on the back end, and quite soon, in a few more videos, we'll start working on the front end. Great, so have an amazing day, and see you next time.